Alright, so this video I'm going to cover hooking up a 3-port boost controller, 3-port MAC valve used for boost control, and I'm also going to cover a 3-port like 4-port. It's using a 3-port valve to get it to work like a 4-port where you can get more out of your spring pressure. So there's just something I want to clarify before I get into the video. I set up a tune that I can control the boost controller with throttle position all the way on. I just want to be clear that I'm not saying set your boost controller up based on throttle position. I'm just saying that I had it set up this way so I can reach it and I have a way to control the solenoid. So wanted to cover that because I know there'll be guys that are like, oh, that's a really dumb way to do that. This isn't like control strategy, it's just like how to do the plumbing. So I'll go over both methods, actuate the wastegate, and then I'll show a data log at the end to compare the difference between 3-port and 3-port like 4-port. Okay, so I was hooking up the boost controller on the truck and I decided I'd do a little boost control video using a 3-port MAC valve and an old wastegate. So this is a 60 millimeter wastegate. I have the feed line coming from my compressor. This would be basically like your boost reference from your intake manifold or your compressor housing on the turbo. I have one line going to the bottom of the wastegate and then one line right now going to the top of the wastegate. And this would be like a typical traditional 3-port boost control setup. So just as an example, I'll turn the compressor on and you can watch the wastegate move. So now what this is doing is I'm getting air coming from the compressor. It's going to the bottom of the diaphragm on the wastegate and it's lifting up the valve. So now as I actuate the throttle, it will take air from here and it will start to feed it onto the top of the gate. So before we go into more detail on that, I want to talk about how the solenoid actually works because I think that's an important piece of it and may help people understand this whole thing a little bit better. Now I have the solenoid set up so I can just manually turn it on and off. So what I want to talk about is how the circuitry in here actually works. So you have a number 1, the right side here is port 1, this one is port 2, and the center is port 3, which is a vent. On port 1, if you actually look inside here, there's a little screen on the inside of here. So another way to look at this is normally open or normally closed. So there's a normally open circuit and a normally closed circuit. If you look at how this is plumbed right now into number 1, this is a normally closed circuit. So if I apply air to port 1, there is no air flowing through the solenoid. When I turn the solenoid on, or I give it power, it goes to open and it passes air through the solenoid from 1 to port 2. So it flows it through this way. So if I switch the ports over to port 2, we now have air flowing through the normally open circuit. And then if I apply power to it, it switches to where it's coming out this side over here. So now you have 100% of your airflow coming out here. Solenoid activated, you have 100% of your airflow coming out here. Air hooked back up to port 1, normally closed. Give the solenoid power, it passes air through the solenoid. So when you have air coming in from your turbo or your intake manifold over here, you want to be able to actuate the solenoid and then send air through port 2 to the top of the wastegate. And that's where your vent comes in. So port 3 and port 2, this circuit here is normally open, so this also acts like a vent. So when you send air through the solenoid this way, it will send it to your wastegate, but then when the solenoid turns back off, it's allowed to vent the air back out through 3 and it doesn't lock the solenoid and lock the air on. So if you go through the opposite direction, I still have positive air pressure in this circuit because it's going to be sending air through here, coming out here, going to the wastegate, but then when I turn the solenoid off, it turns into a normally closed circuit and it would just lock air pressure onto the wastegate. And you don't want that. You want it to be able to vent off. So now I'll hook this up to the wastegate and then we'll look at it working. So here would be wastegate hooked up with just a reference to the bottom of the wastegate, no boost controller. So you have your line coming in from your turbo or from your intake manifold. The line comes into the bottom of the wastegate under the diaphragm, and then when you get air pressure under the diaphragm, it lifts up the valve and then wastes the exhaust gas. So by controlling the release of the exhaust gas, you control the turbo spool and you control your boost pressure. So set up like this, your final boost pressure would be determined by the spring that's in the wastegate and your amount of back pressure that you have pushing up on the valve. So I'll turn the compressor valve on and we'll apply some air to the wastegate and watch the valve move. Alright, so there we have air coming in. You can hear it flowing. It's actually leaking a little bit through the diaphragm. But even just doing that with my finger, you can see how this valve moves because it's holding pressure onto the top when I plug that. Typically that shouldn't be leaking, but that's a different story. So you have air coming in from the turbos or manifold, pushing up on the diaphragm and pushing this valve open. So depending how much boost pressure you have, you may be assisted by exhaust pressure. So my thumbs right now would be exhaust back pressure, also moving the valve around. So that's where you might see different final boost levels using the same wastegate with the same spring on different setups because of the amount of back pressure or how efficient the whole setup is. Your exhaust back pressure may be opening or closing the valve even more. So now let's say we want to control the boost. What we want to do is we want to start adding pressure onto the top of the wastegate to push this valve down and push this valve closed so we're not wasting as much gas. So to do that, we can add air to the top of the wastegate by taking another line and adding it to the top. You can see my valve is open. Now I'm going to take my air reference and add it to the top. So where does that put my final position of that valve? So you can see how much more closed it is. My back pressure is still able to push up on it a little bit, but you can see the valve position there compared to the valve position here. So typically if you have a line to the bottom of the gate and a line to the top of the gate and they're both equal, as we were just showing, that setup would make about double what the spring pressure is. So, and by spring pressure, I mean whatever your reference is when you're just doing a line to the bottom of the gate. So if you're running, even if you have an 8-pound spring, if you run one line to the bottom of the gate and it makes 10 pounds, and then you run a line equally to the top of the gate, it'll make around 20 pounds. So that jump from 10 pounds to 20 pounds might be too much, so that's where you would add your boost controller. So you don't have to put all of the reference to the top. You can modulate how much you put to the top and you're able to control it. So let's do that. We'll hook up the boost controller, which is just a valve, and you can do this with a manual valve also. So now, similar to what I was doing before when I was putting the line to the top of the gate, now I'll modulate it with the throttle. So this is going to be adding duty cycle to this controller, and it's going to be starting it at 0% and then ramping it to 100%. So as I give it a little throttle, you can hear the solenoid working. And then as I give it more, this would be like giving it more duty cycle. It starts to close that valve. All the way to the point where the solenoid is on and I'm applying equal pressure to top and bottom of the wastegate. But I have the ability to control it, so if I didn't want to go equal, I can put half here, I can give it a little bit less. And then I can hold the valve right in the middle. So it's not all the way open, it's not all the way closed. I can hold it right in the middle and kind of modulate where I want it, and I can manage the boost pressure that way. So another thing to add is the valve is all the way open right now, so I'll stroke the valve down to where it's closed, in its closed position. So that's all the way down, but watch when I push on it with my thumb, how easy it is to still open the valve. Now I can give it full equal pressure, and now I'm not able to move that valve at all. So my thumb would be representing back pressure. So with less duty cycle, my back pressure can easily manipulate this valve or open it up a little bit more. If I give it more duty cycle, it doesn't open the valve as far, so that would supply more air to the turbo More exhaust gas to the turbo, give you more boost. All right, so I have this set up a little bit differently now. Still using a 3-port like 4-port, because you're using a 3-port valve like a 4-port would work. What that'll allow you to do is apply more reference to the top of the gate than the bottom of the gate. So if we remember what we were talking about before, this circuit from 2 to 3 is your normally open circuit. So now, instead of having an open line going to the bottom of the gate as a reference all the time, it's going to go through the valve, and this is your normally open circuit going to the bottom of the gate. So you'll always have air pressure here when the solenoid is off. As you start to actuate the valve, it'll start sending air through number 1 to the top of the gate. But in this configuration, instead of maxing out at equal pressure 1-to-1 on top and bottom, you start to close off the reference to the bottom of the gate and you apply more reference to the top of the gate, which forces the valve to be closed more and gives you higher boost level than you would have had before. So the other configuration, you'd be able to double your wastegate pressure. In this configuration, you can triple your wastegate pressure. So I do have a T added on here because this configuration doesn't have a vent. So the 4-port valve actually has a built-in vent. So again, if you remember what we said this circuit does before, this is normally closed when the solenoid is off. So if you apply air pressure to the top of the gate here and then you shut the valve off, you're going to be locking pressure in this line here on the top of the gate. So you want that to be able to vent out. If you don't have a T in it, you could like poke a little hole in the air line also. Or you could drill a hole in the fitting here or whatever, as long as this has a way to vent. So now what I'll do is I'll turn the air back on. We'll watch the valve open and then I'll actuate the throttle and we'll start to move this thing. I'll start to actuate the valve. You can see that it functions very similarly, but now if we give it more duty cycle, we'll be able to give more to the top than the bottom. We'll actually start closing this off, which closes off the reference to the bottom of the gate, forces the valve closed. So now what I should be able to do using throttle position as a reference is I should be able to apply air to the top of the gate, watch when the valve is closed, it's fully actuated, and then see what the throttle position is, hook it up the other way, do the same thing, and then this configuration should close the valve sooner than the other one, meaning that a lower amount of duty cycle on the controller this way will give you a higher boost level sooner. So let's do that. All right, so I have it hooked up traditional 3-port way. So what I'm going to do now is I'll give it reference to the bottom. I'll actuate it until the valve closes, and we'll see how much duty cycle it took to close it. And then I'll hook it up 3-port like 4-port, and we'll see how much duty cycle that takes to close. It's about fully closed. Now we'll hook it up the other way. Now I have it hooked up 3-port like 4-port. Compressor reference here goes through the normally open circuit to the bottom of the gate, and then we're going to apply air to the top of the gate through this. Now it's fully closed. Now we'll look at the log and see what it looks like. Okay, so here's that data log. You can see the 2 big spikes there. This one's about half of what this one is. So this was regular 3-port configuration. It took 88.5% duty cycle on the controller to get the valve to close all the way. So what that would be doing is nearly 100% duty cycle. It's applying air almost equally to the top and the bottom of the diaphragm on the wastegate. So you're almost maxed out there. So now going over here, that took about 38% duty cycle to get to the same point with the valve closed. So at 38% duty cycle, we'll call it half, is the point where you reach having equal parts 1-to-1 on top and bottom of the gate. So once you cross that point, you start applying more pressure to the top of the gate, forcing the valve down harder and making more boost. And that's all I have to say about that.